So now if you saw my last video, you might think this is the same video, but it's actually quite a bit different. We do have a 555 timer though, that has an output being controlled by a light dependent resistor, just like last video. And just like in the last video, when there's enough light, the output's high, so the red LED is lit up. That's not shown on the schematic, which it was in the last video. But when it gets dark enough, the output goes low, and the blue LED lights up. So that happened in the last video too, but the blue LED wasn't on the schematic in the last video. And for this video, we're going to focus on just a light lighting up when it is dark enough. So we're going to get rid of the red LED for now, which was heading to ground. Actually, we're getting rid of it for good for the rest of the video. So we have the circuit here, and the circuit is basically using the same components. Instead of a 100,000 ohm resistor, we have 1 kilo ohm, and it's on the other side of the voltage divider. Light dependent resistor was down there. And in the last video, as I said before, the LED was on the low side. It lit up when the output was high. Whereas we have the blue LED here that lights up when the output is low. But the main takeaway is we get an LED that lights up when it is dark enough in either case. So we just kind of swap the direction things are going. And the other main difference we used was we had a 100,000 ohm resistor on the positive side when the light dependent resistor was on the lower side. That's because we need a very low voltage to get low. So we had quite a bit of resistance on the positive side. And now we have the other case when it comes to the fixed value. To get a low input when it gets dark, we're going to need a low value resistor on the low side to pull that down. Now the pin 2, that is the trigger pin. So 2 there, trigger. Over here, there is just a resistor, 1000 ohm resistor right there going to the negative supply. And we just need that 0 volts there, actually less than 1/3 of the supply voltage. Anything below that is fine. And so we could even just use a jumper going directly to ground. That'd be fine. Current doesn't go in or out. But I just use a 1000 ohm resistor. Any value should work as long as it's not considered like an insulator level. So when the that holds the output high under normal circumstances, which keeps the blue LED off. But when there's light falling on the light dependent resistor, we get a high enough voltage to pin 4 where it doesn't do anything. Whereas when it gets dark, so I'll cover the light dependent resistor, the blue LED lit up. The reason why the blue LED lit up is because electrically I'm basically removing the light dependent resistor as far as the input is concerned. The voltage dropped enough where it sees a low input, and it only sees a high input or a low input. Doesn't know the exact voltage, but in case voltage dropped enough, it gets a low input. It forces the output to go low, and the blue LED lights up. So we're getting the opposite output we did from the last video. The light dependent resistor is on the opposite side of the voltage divider, which is why we get the opposite output. But we have the light dependent resistor on the opposite side of the circuit. So since everything is opposite, we get the same result where the LED lights up when it is dark, whereas it turns off when the light is falling on the light dependent resistor. Now you notice the LED being off, we have about 2 milliamps of current according to this power supply, which isn't completely accurate, but it looks like we are definitely using some power. We're going to get more current though when the LED is on for a couple of reasons. Actually no, the current's probably flowing because we have a lower value resistor here. That's probably why we have current when the power supply is off. But we have that same problem we did in the last video where we couldn't get no current at all when the LED was off. So there's better ways to make this more energy efficient, where there would be no power being used when the LED is off for the most part. But in any case, when the LED is on, so you're going to see more current when the LED is on. We saw, I think, 4 milliamps. Now we're seeing about 9. That is because the 555 timer output connects to ground better than it does the positive supply. and so more current is going to flow. The LEDs are going to get brighter. Of course, if you just wanted to make a simple night light, and this does work as a night light, I've had circuits where I just went to bed with LEDs being on like that, and I can get around my room when it would otherwise be pitch dark. But any case, there you can see I can get it to reflect off my hand. There's a little bit of glow from the TV, but you can see I can get that reflection on there. So obviously if it's pointing in the direction you're heading, it lights up, you know, large objects enough to see them. You won't trip over them or anything if you really wanted to. But in any case, that's it for this video. Hope you enjoyed. Make sure you check out one of the other videos I'm posting on the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.